We ended our last video with a discussion on finding the general formula for a sequence that's going to be able to describe any term within the sequence. And we used this example here where we had a sequence that was made up of 1, 4, 7, 10, and 13. And we found this general formula, which was that Tn is equal to 3n minus 2. And using this formula, we could describe our first, second, third, fourth, and fifth term using this formula, and we were actually able to get each of our terms there. So now we're going to continue our discussion on sequences. And one thing that you're going to encounter when you are dealing with sequences is something that is known as a common difference. So let's use an example to explain the concept of common difference. So let's say we have a sequence that is made up of 10, 6, 2, -2, -6, -10. If we look at the sequence, can we see what the pattern is as we're going from one term to the next? Well, let's just look at from the first term to the second term. When we're going from 10 to 6, we are going to be subtracting 4. And let's say we're going from 6 to 2. We can see that again, we're going to be subtracting 4. 2 to -2, again, we're subtracting 4. So already you can see that there's a pattern here. And you'll see that it's the same pattern for each of these terms here. Here again, we're subtracting 4. And here again, we're going to be subtracting 4. So the pattern in this sequence is that we're going to be subtracting 4 each time. And when we have a sequence like this, where we have what is known as a common difference, this is called a linear sequence. And it's different than one of the sequences that we dealt with in our last video, where we got from one number to the next by multiplying by something. So this is different because we have a number that we are either adding or subtracting each time, and this is known as a linear sequence. And any linear sequence that you deal with is going to have a common difference. And that doesn't mean that you need to be subtracting by a number each time. If you look at the sequence that we ended off with in our last video, we were adding 3 every time to get from one term to the next. And that would also have a common difference. The way that you're going to find a common difference is to take one of your terms and subtract from it the term that comes immediately before it. So you can do, let's say, T2 minus T1. That is going to give you the common difference if we're talking about a linear sequence. You can do T3 minus T2. That's also going to give you the common difference. You could do T4 minus T3. That's also going to give you the common difference. One thing that's important to note here is that we can't do the opposite. We can't do T1 minus T2 or T2 minus T3. So it has to be a term and subtracted from that the term that comes immediately before it. And let's actually do this for these terms. So let's do T2 minus T1. This is T2, our second term, and this is T1. So 6 minus 10 is going to be equal to -4. Let's do T3 minus T2. T3 is 2, so 2 minus T2 is 6 minus 6. That's also going to be equal to -4. Let's do T4. T4 minus T3. T4 here is -2, so -2 minus 2. And again, that is -4. So our D here, our common difference, D, is equal to -4. Now what if we took that same sequence? I'm just going to give myself a little bit more space here. That was our sequence that we just dealt with now, and we found that there was a common difference of -4. And now let's say we were trying to find a general formula for this sequence. Now when we're trying to do that, an easy way to sometimes figure out a general formula for a sequence is to write down all of the terms in your sequence. Then you can make a note of exactly what's happening as you're going from one term to the next. In this case, we are subtracting by 4 each time. So let's look at this first term here. Our first term is 10. And 10 is what we're going to be starting with. So we're starting with 10, and we haven't subtracted anything from it yet. So another way that we can write that down is we have 10 minus 0 times 4. And again, 10 minus 0 times 4, that's just 10 minus 0. So that's going to give us 10. And the reason I'm writing it down like this is because we're going to try and find a trend in this formula as we go from one term to the next. So that was our first term here. And let's put this second term in another color. So 6. Now, if we're working from our first term, which was 10, how are we going to get to 6? Well, we're going to be subtracting 1, 4. So we're going to go from 10 minus 1 times 4. And 10 minus 4 is equal to 6. Now let's look at our third term here. If we're starting from 10, how are we going to get to our 2 here? Well, we're starting from 10. We're going to minus 4, and we're going to minus 4 again. So we've subtracted 2 4s. So we're going to go from our 10, we're going to minus 2 times 4, and 2 times 4 is 8. 10 minus 8 is going to give us 2, so that's correct. Now let's look at this term here. We are going from 10, we are going to subtract a 4 here, subtract another 4, subtract another 4. So we're subtracting 3 4s. And another way we can write that is 10 minus 3 times 4. And again, minus 3 times 4 is minus 12. 10 minus 12 is negative 2. And we can keep doing this with each of these terms. And one thing that we can now see is that this part of our formula is staying the same in each of these cases. So the only thing that's actually changing is this number here. We're starting with 0, then we have 1, then we have 2, then we have 3. And if you are trying to write that down in terms of an actual formula, we can write that down as 10 minus something times 4. And we're going to have to write down this something that we're multiplying by 4 in a way that is relating to n, so that we can find our general formula for n. Remember, we want to know how we can solve for our nth term in a series. So how can we write down what we're multiplying by 4 in terms of n? Well, we know that this is equal to t1, this is equal to t2, this is equal to t3, and this is equal to t4. This is just our first, second, third, fourth term. First, second, third, fourth term. And so when we're dealing with our first term, when n is equal to 1, we're multiplying by 0. When n is equal to 2, we're multiplying by 1. When n is equal to 3, we're multiplying by 2. And when n is equal to 4, we're multiplying by 3. So if we were to put this in terms of n, we're going to be multiplying by n minus 1. And that means if we're dealing with our first term, we're going to have 1 minus 1 times 4, which is 0 times 4, exactly what we have here. When we're dealing with our second term, n is equal to 2, 2 minus 1 is 1 times 4, and that is exactly what we have here. When n is equal to 3, 3 minus 1 is 2 times 4, and that's exactly what we have here. And it's going to work for every single one of these terms. So another way that we can just write this down is 10 minus 4 and minus 1. That's exactly the same thing as here. I always just find it a bit easier to read when it's written like this. And we can actually simplify this even further just to find an even simpler general formula for a term. Let's say we were actually going to multiply this out. That would be 10 minus 4n plus 4. And so we can simplify that to 10 plus 4, and that's going to be equal to 14 minus 4n. And our general formula for this sequence here. And let's just test this out with, let's say, our first term. When n is equal to 1, 4 times 1 is 4. So 14 minus 4 is going to be equal to 10. That does give us our first term. Let's say n is equal to 2, our second term. 4 times 2 is 8, so 14 minus 8 is going to be equal to 6. And that's exactly what we have here. And you can try this out with each of our terms here, and you're going to see that this formula holds for a general formula to find any of our terms in this sequence. So for this sequence, Tn is equal to 14 minus 4n. Let's go over another few examples to make this even more clear. Let's say you were given the following sequence: 10, 7, 4, 1, and -2. And the question was to find the common difference, to find d. Now, we learned that when finding the common difference, we're going to find a common difference by looking at Tn and subtracting from that Tn minus 1, and that is going to give us d, our common difference. So let's actually use this formula to try and find d in this sequence, our common difference. So when looking at Tn minus 1, we can do, let's say, T2 minus T, well, our n in this case is 2, so n minus 1 is 1, so we have to do T2 minus T1, and that's going to give us d. So in this case, T2 is 7, so 7 minus T1, which is 10. 7 minus 10 is equal to -3. So our d in this case is equal to -3. That is our common difference. Let's try that again with the next set. So let's do T3 minus T2. T3 is 4, T2 is 7. 4 minus 7, 4 minus 7 is going to be -3 again. So again, d is equal to -3. And so our common difference here, we can do that for each of these terms here, and we're going to still find that our d is going to always be equal to -3. So we have a common difference of -3 in this sequence. And again, when we can find a common difference, when we have the same common difference in each of our terms, that is known as a linear sequence. Now let's say we were dealing with an example that didn't have a common difference. That would be an example of a non-linear sequence. And let's go over one such example right now. Let's say we had a sequence that looked like this. We have 9, -7, -8, -25, and this is our sequence. Now let's use the same formula that we learned to find a common difference, which was Tn minus Tn minus 1 is equal to d. And let's see what happens if we try to do that with this sequence here. So let's start with T2 minus T1. So that would be -7 minus 9, and that is equal to -16. Now let's do T3 minus T2. -8 minus -7, -8 minus -7 is going to be equal to -1. That's the same thing as -8 plus 7. Now let's do T4 minus T3. -25 minus -8 is going to be equal to -17. Again, because that's -25 plus 8, which is -17. And what we can see here is that this number is different from this number and is different from this number. Each of these are giving us different numbers. There's no common difference. And when there's no common difference, we know that we are dealing with a sequence that is not linear. The sequence is not linear. So you can always determine whether a sequence is linear or not by looking at whether there is a common difference. And when a common difference doesn't exist, we know we don't have a linear sequence. And we can easily tell the difference between this and the example that we dealt with just before this here, where we had a common difference of -3 each time. So this did have a common difference, therefore it was a linear sequence, whereas this example here did not have a common difference, so it's not a linear sequence.